In this section of chapter 10, we're going to be talking about gas stoichiometry. So gas stoichiometry is basically what you've learned so far in the semester about stoichiometry, things like percent yield, limiting reactant, converting from mole to mole using the stoichiometry and the information in the question. The only new thing here is we're going to be adding the ideal gas law equation to figure something out, volumes of a gas, for example. And these are the problems that I'm going to be focusing about. So let's start with the first problem. It asks here what volume of nitrogen, and the volume you're required to find will be in liters, measured at 98.0 kilopascals and 26 degrees Celsius, is produced when you have 75.0 grams of sodium nitrite decomposing. So in this case, you are given the initial grams of your reactant, and you are simply going to convert from grams of reactant to moles of the product, and then take the moles of the nitrogen and convert them to using ideal gas law, PV equals to nRT, to the volume of nitrogen. So let's start doing this. So first things first is I will say convert from grams of sodium nitride to moles of nitrogen. And this is so easy. We will take the 75 grams of sodium nitride, and then I will convert to moles using the molar mass. And by the way, this information will be given to you on the exam, the molar mass, etc., to save you time. So 65 point, if it's included on the exam, 65.02 grams of sodium nitride. And then finally using the mole-to-mole ratio of sodium nitrite to nitrogen. So I would say 3 moles of nitrogen to 2 moles of sodium nitride. Let's double check. Everything checks out. Yes, that's perfect. So in this case, I would get 1.730 to 3685 moles of nitrogen. Okay, now let's check our sig figs really quick. 3 sig figs. I have here 4 sig figs. This is infinite, so 3 sig figs. Now, the second thing is once I obtained the moles of nitrogen, I'm going to use PV equals to nRT. Now, look, there is the number of moles. I'm given the pressure in the question, which is 98.0 kilopascals. I want to find the volume in liters. I must be able to match all the units in the problem to the universal gas constant, which is 0.08206 liter atmosphere over mole. Okay, by the way, this is given to you on the formula sheet, times the temperature. Temperature is 26 degrees Celsius, but note the temperature is in the constant is in Kelvin, so we must convert it to Kelvin. So let's lay out our information. So 98.0 kilopascals. Note that the pressure is in atmosphere. So I will convert from kilopascals to atmospheres, which is this, by the way, conversion is given to you on your formula sheet. No need to memorize anything. Times volume, which I want to find, times the moles, which is given to me right here, or I already determined it. And I'm going to multiply by 0.08206. Okay, times the temperature. So let's change the temperature, 26 plus 273.15. One thing you need to be aware of is you don't only have a multiplication division operation in these type of problems, you also have an addition subtraction. So I will also write out the sig figs. So because I have no decimal places, it becomes 3 sig figs. So 3 sig figs, this is infinite sig figs, 3 sig figs, and then I have this, by the way, is a measured value. Although it's a constant, this value is obtained experimentally, so the sig figs are counted. And from my question here, the least amount of sig figs is 3, therefore the volume right here, and wait and round till the final answer. So the digits on my calculator give me 43.91537684 liters. Okay, and we're going to round to 3 sig figs, therefore I have 43.9 liters. Now, I have a different type of problem right here, which is the percent yield. I highly encourage you again to do this on your own, or if you just want to do it with me, that is fine, but doing it on your own, you've learned this before, you can do it. So let's start. We're again sticking with the same theme of sodium nitride. Now, you are having now 75 grams of sodium nitride is decomposed, and you're given the pressure 740 torrs at 27 degrees Celsius. What is the volume of nitrogen? So the idea is the same, is a similar, very similar idea to a past question. And in this case, you are given the percent yield this time, and you want to determine again the volume. So let's see how we are going to do this. Very similar. We are going to first, let me copy and paste the equation from here. So we're following. The same theme. Okay. And the beginning of it is very similar. Why? Because we are going to again start by finding the number of moles produced from that 75 grams of the sodium nitrate. So actually, let me copy and paste it from the beginning right here. So we're following. Okay. And in this case, I'm starting again with the 1.703 302,368 moles of nitrogen. Now, this right here is the anything obtained by calculations in a question is your theoretical yield. Okay. And we said theoretical yield can be moles, can be grams, can be even enthalpy. It can be anything. So in this case, I can say that the second step would be if my percent yield is 91.0 equals to actual over the theoretical, and I will copy, paste here, of nitrogen times 100. Therefore, the actual yield becomes 1.57475773 moles of nitrogen. And note here, let's track our sig figs. So we agreed from the first part, it was already 3 sig figs. Percent yield is 3. This is 3, then 3 sig figs. Now, again, I'm going to use the ideal gas law. Let me move to the next slide. So I'm going to say the third step is we are going to say that PV equals to nRT. And the pressure now is given to me in torrs. Let's write out the ideal, the universal gas constant. Okay. And double check. Oh, okay. I know I will have to change it to atmospheres. So this also conversion is given to me on the formula, given to you on the formula sheet, 760 torr. Okay, times the volume, which equals to here. Now, let's see what are the actual moles. The actual moles, I determined them, or the actual yield. Okay, in moles. And I want to give room for myself, times R, which is 0.08206, times the temperature. Now, temperature again is 27 plus 273.15. Okay, and this will be in Kelvin because of the constant. And let me now track my sig figs. So I have here, it's 740, it's three sig figs. I have here 3 sig figs, and the 27 plus the 273.15 will give me 300.15. So it will be 3 sig figs as well. Therefore, I can say that this is infinite. This is 3, 3, 4, and 3. So lowest amount of sig figs is 3. So volume equals to 39.83506056 liters, and which is 39.8 liters.